page 9 and 10 of differentiation bookwork. We are going to be drawing tangents today, and a tangent is a line which follows the gradient of a point on a curve. So like for example, if you have a parabola, if you wanted to find the tangent of this curve, remember how in our mosaic investigation we put a tile over here which had a straight slope which is approximately the same as the curved slope here. Now a tangent would be a straight line which goes through that point following that slope. Okay, so theoretically it touches this parabola at one and only one point. It touches exactly at one point. Luckily the calculator can do this for us. So we're going to do these. We're just going to do every other one. So let's start with A. It's just the regular quadratic parabola y equals x squared. So the first thing we're going to do is we're going to program it, the function in the calculator. So we put x squared, and then we'll graph it. And then it says that it wants to know what the tangent line would be at 3, 9. Actually, we only need to know the x coordinates. So we just look at the 3. We don't need to look at the 9. They're giving us the y coordinate also, but we do not need it. So we take the 3 and we are going to draw a tangent. So we do second draw. There we go. And then we go down to tangent number 5. And then we hit 3. Okay. And then it will draw a tangent line through the x equals 3 point, and it gives us the equation. And it wants the equation in the form y equals mx plus c. So it gives it to us in the exact right form. So it's y equals 6x minus 9. Okay? Now let's do the e. So it is 2x squared minus 5x plus 5. So we will program the new formula in here. So it would be 2x squared minus 5x plus 4. Okay, and then we will graph it. And then we will second draw the tangent line. Second draw. Tangent line 5. And then we want the tangent line at x equals 3. So we'll hit 3, enter. And the tangent line is right there. And the equation for the tangent line is y equals 7x minus 14. Okay? Now we'll do I. 4x squared minus x cubed. Four x squared minus x cubed. Graph it. And then now we want to find the tangent line at x equals 4. So we do second draw. 5. And we hit 4 for x equals 4. Enter. And it's going to be y equals negative 16x plus 64. And we just ignore all these extra digits here because those come out because the calculator is not actually taking derivatives. It is estimating derivatives using, computer programs. So sometimes it doesn't come out to the exact whole number, although these problems are supposed to give you whole numbers. Okay, let's do m. 1/2 x to the fourth minus 7. So we'll program that in. Y equals x to the fourth minus 7. Oops, it says 1/2 times x to the fourth. So we could do x to the fourth. Maybe we could do 0.5 times x to the fourth. That would be a way we could do that. 0.5 x to the fourth minus 7. Okay, we'll graph it. And then we're just going to put in, we're going to find the tangent at x equals 4. So we'll do second draw tangent 4. X equals 4. Oh, wow. Look at that. It's almost straight up and down. Y equals 128x minus 391. Okay. It's even off the screen. It's way up there. The tangent line is intersecting, or it's not intersecting, but it's touching the graph way up there. Last one, Q. Y equals 3/4, which is 0.75. I'm just going to 0.75. It makes it easier just to put in the decimal, because then you don't need to worry about PEMDAS at all. 0.75x squared plus 3. Alright, that's this one here. And I need to check out the tangent at x equals -2. Second draw 5 -2. Oops, not 0.2, -2. There we go. So that one is going to be y equals -3x. Then at the very end, it gives us a couple more. Find the equation of the tangent of the given curve at the stated point. Give your answers in the form ax plus by plus c equals 0. This is a little bit harder because, as you noticed, the calculator gives it to you in slope-intercept form or gradient-intercept form, and this is standard form, but I'll show you how to adjust the answer so that it comes out the way you need it to. We're going to put 12 divided by x squared, so that we could write that as 12x to the -2, or we could do 12 divided by x squared, graph, and then we're going to do a second draw of the tangent line, and it would be at -2. Well, I'm sorry, +2, right? 2. That's this one here. And it's going to give us a gradient-intercept form of y equals -3x plus 9. Now to change that into standard form, you can see that we're going to put 3x on the other side, so we add 3x to both sides, which will give us that. And then we subtract the 9 to the other side so that we have 0 on the right. So we have 3x plus y minus 9 equals 0. Okay? And then for e, we just program this in here. 5x minus 8 divided by x. Now, PEMDAS tells us that the 8 divided x is going to be done first. You could put this in parentheses if it makes you more comfortable. Graph. And then we're going to look for the tangent line at x equals 4. So we go second draw, tangent, 4. And we get the line y equals 5.5x minus 4. And let's subtract y from both sides. That'll give us that, and then we're already in standard form. Sometimes standard form is given as, oh, a has to be a integer, and if that's the case, you need to multiply all this by 2 so that you get integers, but otherwise this is fine. If they never say that it has to be an integer, that's fine. Okay, so that's in standard form. Okay, and that is it.